Hi, I'm Raymond Gann. We've all seen great moments in movies, TV shows we'd love to see again, but it's hard to quickly discover them. It's slow to scroll through multiple TV episodes or long movies. Maybe you're a video editor making movie trailers or social media clips, or an advertiser checking product placement, or you're a content moderator, lawyer who must search for objectionable content. Well, my in-video search system does just that. Inspired by Netflix's tech blog Building In-Video Search from 2023. I built my own in 3 days at Tubi's October 2025 company hackathon. You can search inside multiple videos by dialogue, descriptions, people, objects, or scenes. You can search by speech, by images, or by a combo of both in a search that understands context, linking images and speech together in semantic spots called vector embeddings. You can try it yourself at raymond.hop2.org. Now, I processed 2 short videos from season 1, episodes 1 and 2 of the British comedy, The IT Crowd. It's my favorite comedy on IT people. So these are already processed. IT guys always say, have you tried turning it off and on again? Let's search for this direct dialogue quote. My app will find and play videos from this exact moment.
Hello, IT? Have you tried turning it off and on again?
Let's try searching for a video description, like women in elevator. Women elevator search.
Good luck.
There we go. Get this. You can get here.
Left. Get out of the left.
Get
out of the left. Get out of the left.
This is Jen coming out of the elevator. All the scenes from episode 1 for her doing that. Let's try a more tricky search, which is woman walks by red shoes in a window. Now this requires visual understanding and context, not just looking at speech. Oh, look at all these results with the red shoes. So Jen, the IT manager, walks by the window, comes back. Perfect. This is from episode 2. Okay, let's try old woman falls downstairs. Oh, this is actually, whoa, she gets up again. And, oh look, I think she falls the second time. This is actually a commercial for a fake 911 service in the UK. It's hilarious. Let's check TV ad. Can we detect this? And, oh. Here we go. So this is for a fake, comedic version of a 911 ad. They give you like 20 numbers to call for an emergency. It detects that it's a TV commercial, which is amazing. Let's see if we can search for the actual number in the ad. Oh, wait, 118999. Look at that. It actually finds all these images that have the number and the actual commercial where they sing the number. Pretty amazing. Let's try searching for another direct quote. In this case, I am declaring war.
I am declaring war.
Perfect. And you notice all these other searches are related to someone talking about war. Let's try a visual description. Just trying on shoes. I just put this in because it's hilarious. Notice all these shoe images and videos.
Sue, lean in with the shoe.
Jen tries to put on a shoe that's too tight. Let's try our own search. Let's put in something like angry face. Let's just see if it. Oh, look at there. There we go. Jen and the sales lady, angry. Oh, and the other guy, the manager, also declaring war. Notice all the angry faces it finds. Perfect. Now, how does this work? When you process a video, it intelligently breaks a video into shots. One shot is a few seconds of video. A scene is made of several shots. For better search results, my code saves 3 images per shot, 3 thumbnails. This is called multi-frame pooling, which Netflix also uses. With the NVIDIA GPU chip, processing a 6-minute clip takes 35 seconds. Before video processing, you may pick what's called a shot detection threshold. And a lower number of the threshold means it's very sensitive and takes many short shots. Higher means it's less sensitive and takes fewer longer shots. For each shot, it makes a vector, a numerical fingerprint of what's happening in the frame. A vector is just a list of numbers. It's from OpenAI, showing OpenAI's clip model. I used OpenAI's clip model to link images to vectors. Which is on the lower left. And then I used OpenAI's Whisper model to link speech to vectors. This links the images and text together, as you see, and calculates a similarity score. These vectors get stored in Facebook AI Similarity Search, or FAISS. These embeddings, as they're called, vector embeddings, let us compare similarity scores between text and images for one item with text and images for another item. Let's look at a different image here. This is a graph of what's called cosine similarity. Let's say this photo and text for a large dining table and one for a fax machine go here in this embedding graph. Then we get photo and text for big room with table. Where does that map in this embedding graph? Closer to the photo and text for the first table, right? You would think. So the big room with table and large dining table both are closer to each other. Note the angle between the vectors of these two tables is closer in this graph than between the vectors for a table compared to a fax machine. So this whole thing, looking at the vectors in this vector embedding space for an object and comparing how close they are by angle, this is called checking cosine similarity. That's how we know one image and text in our vector embedding is a better result in our search. Last thing, I'll talk about tuning our sliders. So we have, in these results, we can move these sliders around and check 2 things. One is top k nearest neighbors. The other is search importance, and this is called an alpha factor. Top k nearest neighbors, basically the lower number we pick, the fewer search results we get, but the more accurate they become. So let's see here for angry face. Let's look for red shoes. Let's look for this. You can see here, red shoes. Like this is going to be very less accurate, right? And then for this slider, search importance, this is an alpha value, and the smaller the number, the more we can search for search that focuses on speech, on dialogue. This is what I used to search for better results for quotes, right? Like this. Have you tried turning it off and on again? You get the exact transcripts. But if we want to search for something more focused on images, I turn the slider up closer to 1, and I can search for something like, let's say, man with glasses and big hair. This gives us the results for Moss, the main character. or we can put something in between, typically 0.6, to balance, 60% images and 40% of a search for dialogue, for example, if it's 0.6. I hope you enjoyed my demo. My coworkers voted my project in the top 18 out of 62 projects at our hackathon. I'm very happy about that. And finally, if my website doesn't play for you now, sorry about that. It's to save money. I set up a Nebius virtual machine to run it in the cloud on an NVIDIA H200 GPU. Nebius charges me hourly to run its virtual machine, so I only run it in my site for demos. Thank you so much. I hope you enjoyed watching this.